So, these are the three climates as we are talking about: main climate, hot dry desert climate, warm humid climate, and composite climate. I will come to them. And I was talking of Mumbai, which has got less daily variation. So, monthly mean, maximum and minimum have been plotted here, and you can see this variation is not much really. It would be order of around 5 degrees or so, 5 to 7 degrees. I have more details of this. Relative humidity, of course, the here 90% most of the time in the month of February, March, April, May, June, July, August, etc., you will have high humidity all the day, high humidity all the day, and lot of rainfall. This is the precipitation. So, you will have 600, 750 here. So, huge precipitation during that period of time, and it is humid. So, the name is warm humid climate, right. Indian code of course classifies in a slightly different manner. I am trying to tell you the principle first, then I will come to how Indian codes, ECBC energy code in India or national building code classifies them. They do it in the same manner. And also you will see that wind direction, because it is during the monsoon period, wind also will be high, and direction will be coming from the Arabian Sea side, southwestern, it is called southwest monsoon, am I right? And in Tamil Nadu, of course, during the winter, so called winter season, they also get a rainfall, that is northeast monsoon, because Tamil Nadu and those areas, because you see 8 degrees is Thiruvananthapuram or somewhere around that is 8 degree. So, you are very close to the equator, right, which passes somewhere through Sri Lanka, Addis Ababa and all those, that line, right. So, Tropic of Cancer, and that area there is a heating up of the ocean water. So, moist air will go up. Similar thing which happens in summer, the northwest monsoon, that kind of air movement, moist air movement takes place in December. Australia, for example, the summer is sometime, what is during our winter period, because sun has gone to the southern hemisphere, right. So, the moist air comes, and then when it hits the eastern Ghats, there is a precipitation in the Nilgiris and eastern Ghats. On the eastern side of it, there will be precipitation on those sides. So, they have October, etc., they have rainfall during those period of time. So, that is also warm humid scenario. So, you will find precipitation, then wind direction is dependent on that. Wind direction, prevailing wind direction will be dependent on that. So, in Mumbai you will find high wind during this similar time, and then you have sunshine period, sunshine hours, right. So, sunshine hours, because cloud cover, sunshine hours will be, daytime is longer, but cloud cover etc. is also important. So, this is how actually mean solar radiation is here. How much is the solar radiation on horizontal plane, direct and the diffuse, these diagrams are given. So, one can give a diagram of this kind to represent the climate of a given place. Similarly, hot dry climate, which is Bikaner, receives very little radiation, as I said, rainfall, because precipitation you will see the order is around 100 maximum, precipitation is 125, rainfall is and Mumbai it was 750, scale was maximum 750, it practically does not receive any radiation. Relative humidity is maximum is 60, it can go as low as 35 or so, maximum relative humidity. In the month of May, April, May, it can go much lower, and minimum humidity is still lower early in the morning. So, humidity range is not between 35 to 60, and sometimes it is between 40, maximum is 40, minimum is 35. So, very dry situation. Temperature is much higher here, you see this scale is up to 50, Mumbai the scale was 40, perhaps somewhat less, temperature was this was 50, but this never went beyond 40. So, this is characterized by, and this gap is also larger, you can see this gap is also relatively larger, that was 5 to 7 degrees, here it will be about 10, 12 degrees or even more, can be more. So, rainfall is less, wind direction, prevailing wind comes, desert wind, there is something called they call it locally Andhi, dust storms. So, you find dust storms in part of the western and northwestern India, even northern India, here also it used to come. Now, of course, lot of greeneries that has reduced down, and then mean solar radiation is relatively high, and sunshine hours is also 8-10 hours during the summer months. Okay. That is Bikaner, the desert, desert, basically hot dry desert climate also sometimes we call it. Then large diurnal variation of temperature up to 25 degree in summer or winter. So, daily variation can be as large as this. Very low humidity 10 to 55% in summers, low rainfall maximum 100 in a month, and high mean solar radiation direct and strong, and high local winds inclusive of dust storms during the summer, right. Warm humid, fairly high sunshine hours 9 to 12 hours, low vegetation. The reason why the written ones are coming right now, I did not discuss about the composite climate as yet. So, usually clear sky, brightness of the sky is very high and near horizon is very bright, Warm humid climate, what we have seen, lower diurnal variation, daily variation is less 5 to 7 degree, that is what is said in Mumbai. Coastal India, Singapore, these are examples, and examples of hot dry desert climate, examples are not given, but Bikaner is one of them I given. Then high rainfall, precipitation can be 5,000 millimeter per year, high humidity mostly 75%, 55 to 100%. Mumbai you have seen during the rainy season, it is near 100% all the time. Anyone coming from Mumbai, you can realize this, right. Cloud cover high brightness especially near horizon, and wind speed could be as high as 30 meter per second, but obviously not dust storm, there will be no dust storm, lot of greeneries. Now, when I say composite monsoon climate or composite monsoon climate, it means it is composite of the two, both features are there. So, composite monsoon climate, you will have some hot dry months, some months warm humid, and some months cold dry period as well. Now, this is because of Himalayan scenario. For example, if you consider North India, North Central India, you have a dry summer, right, but as soon as the monsoon comes, the rainfall starts. Monsoon comes because during the dry period, ocean, the moisture, the moisture bearing air from the ocean will move northwards, they will come in contact with the cold air in the mountain, and precipitation would occur, and therefore, this precipitation essentially changes the temperature, lowers it down, but it increases the humidity. So, you have a hot dry season which is because of the Tropic of Cancer, tropical zone where sun rays is very high, but then once the monsoon comes, there is a dramatic change, temperature comes down, rainfall and humidity increases, rainfall is there and humidity increases. So, you have a summer period and then you have a rainy season period which is like warm humid. Summer season is almost like desert scenario, and then you will have a cold season also, small cold season also. So, variable sky condition, directional winds, because you have got it is mixture of both, So, basically you will have some summer season, dry summer season, some warm season, warm humid season, and a little bit of cold season. So, it is mixture of all, that is why we call it composite, and it is actually largely controlled by the monsoon scenario. So, we call it composite monsoon climate, right. So, this is so diurnal, hot dry maritime is a subclimate. Okay, so that is the main climate. Subclimate, there is a subclimate of the hot dry desert climate also. For example, city like Karachi, right, anything in the desert area, but close to the seashore, that gets modified because of the humidity that comes from there, but not as much as the warm humid. So, it is dry, relatively drier, it is somewhat, it is very humid and temperature does not get as lower as warm humid. So, usually hot dry maritime climate is diurnal range is relatively less, high humidity, but high temperature also. So, most of the features are with the hot dry desert climate sort of, but there is a humidity is higher, in fact, it can be extremely uncomfortable scenario. So, the places say located to the seashore in the Arabian Gulf, desert area, but close to the seashore, that can be very uncomfortable, of course, unless you are sitting inside an air conditioned room all the time, so then fine. Then there is something called tropical island climate, which is upland climate, which is at high altitude the climate would change because solar radiation received would be less. Temperature is somewhat lower, as we have seen also earlier in our earlier discussion, and they have diurnal range is relatively high, high relative humidity, precipitation is somewhat higher in those altitude, wind velocity is high due to trade winds and many other characteristics similar to warm humid climate. This is, I think, island climate. No, this is not correct. This is island climate, tropical island climate. These features are for tropical island climate, high relative humidity, high precipitation, tropical island climate. Singapore, West Indies, Philippines, many of them exhibit this kind of climate, where you have actually they are in the warm humid zone, but because surrounded by seashore. So, when a location which is otherwise in the desert, but close to the seashore, it becomes maritime desert climate. When it is warm humid otherwise, but close, surrounded by sea, all the Andamans for example in India. So, they are, that temperature would come down, precipitation would be really very high, and that is called tropical island climate. Upland climate is somewhat modification that bring down the temperature. So, altitude in tropical areas also places like they moderate the climate. So, you have places like say Uti in Nilgiris or even Deccan, many places the temperature is much lower, Pune, Bangalore, their temperature is somewhat lower, they get moderated because of their altitude or situation of the similar kind, surrounding effect of the surrounding. So, these are the climatic zones, this gives you rough idea. Now, according to the climatic zone, you can design or plan your building, but today with the advent of modern computational capability, the thumb rules are not so important, and also the style of building styles have also changed, because you want to house a lot of activity or a lot of population into a single building, right. So, basically even living style has changed. Maybe 200, 300 years back, it would have been 2-story, 3-story building only. I mean, 1 2-story building only, not even 3. Maybe even 4 5-story building didn't come because the lift was not there. Till Mr. Otis actually showed that a lift is safe in 1832 or something in US, 1832 I think, if the year may not be correct. Nobody was ready to make anything beyond 3 stories. But today things have all changed, and therefore, thumb rules are not so important, but you must understand. So, climatic understanding gives you what type of, for example, if it is a hot dry desert sort of climate, the humidity is less, right. So, planning of the building would have been good old days, they would have planned it with a courtyard. If you see the traditional housing in Indian scenario, you go to Rajasthan, say Ajmer, Jaisalmer, those areas, you will find also locally stones are available, thick walls, would use thick walls, traditional I am saying, and thick walls would store the heat during the daytime, because diurnal variation is very high, and morning it becomes relatively cold outside. It maybe a little bit you would like to cover yourself up or something of that kind. So, at that time, large thermal mass of the thick stone walls would radiate it inside. It would store the heat, radiate it in the morning or later part. Daytime it absorbs, late night it would be actually transmitting. Traditionally, by experience, people have actually designed, planned building like this, and you will find courtyard type of building with a small kind of a water pot there, because they do not have too much of water. So, water pot there which they use for it will be evaporative cooling, and there are various other kind of passive system traditionally people have used to get thermal comfort, right. So, that was according to the climate. But you look at northeastern India or Kerala, you will find very thin wall, gable roofed, to shed off the rain, because a lot of rainfall, light, lot of bamboo construction in the northeastern India for 2 reasons. One, you do not need to store the heat. What you need is lot of air movement. Relative humidity is high usually. So, you would like to cool by taking away the moisture vapor from the skin. So, therefore, a lot of air movement, lot of open areas, and since rainfall is high, you will find pond here and there, lot of water bodies you will find, and then I am just quickly telling you the traditional housing would have used that kind of concepts of the climate. Also, interestingly, in northeast India, it's in earthquake zones 5. So seismicity is very high. Therefore, lightweight construction helps there. They would, construction would match with the requirement, traditional housing, but they were all 1 story, 2 story. Today you want to change them, there has been a change. So engineered system has come in, and but such thumb rule of wall requiring high thermal mass in hot dry desert climate, requiring lot of ventilation or fenestration as we call it. Fenestration is the area opening left in the wall by design, required in warm humid climate, that possibly you do not require this thumb rule, but still it is a good understanding you should have. Then one, if it's an engineered building, then you can obviously use your mathematical tools, the software and the physics and everything put together, but the climatic variation has got some relevance. So to that extent it is fine, but otherwise you would be numerically you would be able to design the system or calculate this kind of thing. So design is more, it can be more formal and systematic now. Okay, coming back to site climate is okay. So this is climatic zone. Site climate is associated with local variation. Site climate is associated with local variation. For example, if we like if we pave the area too much, the surface runoff will be too high, which means the evaporation loss from the ground will be less. Too many concrete building will store the heat, and temperature of an urban area can be at least as much as 8 degree higher than a similar area where there are a lot of greeneries. So these are called site climatic changes. If I have tall buildings, that will block the air movement, that will obstruct the daylight, light coming to the certain, maybe some areas become shadow. So these are site climate. So local variation due to changing topography, urbanization, vegetation, modification of climatic condition due to local factor, we call it site climate. Atmospheric science people call it microclimatic variation. Temperature inversion also do occur. For example, during daytime, sun's radiation falls onto the ground, and you have higher temperature near the surface by the afternoon. In the night, surface radiates the heat, the temperature of the surface becomes cool, where somewhere at the top, some height, small height above, temperature remains same. So temperature, this is the phenomenon of temperature inversion. Near the surface, there is a change from high temperature to low temperature, from day to night. So humidity variation also, it varies with altitude and so on. And construction of tall buildings can disrupt rainfalls, etc., etc. As I said, because for example, if the monsoon direction is from east to the west and you have tall buildings in the eastern side of the urban area, there can be orographic effect or rain shadow. But in a larger scale, for example, you might have heard of monsoon, Cherrapunji, where there is the highest rainfall in the world, but Shillong the rainfall is much less, because monsoon is on the southern side of the hills of Meghalaya. So the monsoon rain coming through the Bangladesh, monsoon wind coming through the Bangladesh hits the Meghalaya and precipitates there, majority of it. But Shillong is on the northern side, so it is actually a rain shadow area. You would get much less rainfall. You do get rainfall much more than obviously the desert area and those, but compared to monsoon, Shillong is much less. This thing can happen in an urban area also. Tall buildings can reduce down the rainfall pattern in some other places. So this is called site climate. Solar radiation, mutual shading of one building by other. These are taken care of in urban planning. These ideas must be there. Gradient height, as we said, velocity, wind velocity, it increases with the height, and gradient height changes. Topography, if it is all rough, gradient height is more. If it is plain, gradient height is less. So that's it. Vegetation would change. For example, vegetation would increase the humidity, right? Even in a desert, for example, Jodhpur, city of Jodhpur. After the Indira Gandhi canal has come, it has become somewhat green. So, temperature on close to those canal area, it has reduced down, but humidity has increased. So, that kind of changes could occur. Pavements reduces the evaporation, etc., local rise in temperature due to lesser cooling. This is a site climatic effect. Also buildings store heat, which increases the temperature also, heat capacity of these masses, thermal masses. So, but it is very difficult to take into account all this site climate, because it is not very easy to take into account, but we must have some idea. I mean, one can do, future somebody will do the modeling, but then what is going to happen tomorrow, how it is going to change, you do not know. At the current state of affairs, there are some modelings available and people are trying to do, but this is on the research area. So, you have to actually take into account all the buildings that is there, and with possibly satellite map, you can find out how many buildings are there. Some people are trying to do research on those, urban heat island as is called, and so on. So, this is still in research stage, but site climate do modify. So, when you are planning a new building, designing a new building, some idea related to the site climate should be there with you. So, tropical climate, as you see, this is summarizing this. Air temperature, if you see in this table, which you will be able to see, of course, not in the screen, I am not very sure how much it is, but whatever I said is summarized in a table like this. See, mean air, if I look at the air temperature, warm humid climate, diurnal variation is low. Hot dry desert, diurnal variation is high, diurnal range is high. Composite monsoon, high during hot dry season and less during warm humid season. Air temperature, mean daily maximum temperature is generally, ranges are given 27 to 32 in warm humid, but in summer in hot dry desert can go up to 43, 45. Libya, Tripoli 50, many of those Pakistan cities, Jacobabad used to have very high temperature. I do not know, it is still the highest temperature where temperatures go high. In New Delhi it goes to 42, 43 easily. In somewhere in Jaisalmer it will go to 47, 48. Many of those places, those areas, desert it could go 42, 40, 43, 49 range, and winter may be much less, 27 to 33, 32. So, see the variation, seasonal, yearly variation is also high. Then hot dry season in composite monsoon climate, you will have high maximum temperature, and warm humid season you will have again similar as warm humid climate, because composite is always mixture of the two. So, it will have both the seasons. Mean daily temperature, minimum is usually close to the mean daily maximum, and in case of hot dry desert climate, in winter it can be pretty low. Again composite is a mixture of the two. Humidity in warm humid climate, it is generally high, 55 to 100, and hot dry desert it is less. Composite again mixture of the two. Precipitation usually high in warm humid climate, 2000 to 5000. In hot dry it is 50 to 155, much less. Annual I am talking of, and monthly also sometime it can exceed more than 500 in warm humid climate, but in hot dry desert climate it is much less. Composite again mixture of the two. Sky condition, luminance usually very bright sky in hot dry desert climate, and somewhat I mean bright sky in usually both the scenarios, hot dry as well as warm humid climate. Cloud cover would be there in case of warm humid climate. Solar radiation diffused but strong, and here also direct and strong in case of hot dry desert. Wind velocity low usually, but you can have in warm humid climate during monsoon season you can have storms, and there you can have hot dry climate, you can have dust storms during the dry summer season. So, vegetation grows quickly in warm humid climate, doesn't grow because the moisture is not there. If you supply moisture, it will grow quickly there too. Examples of warm humid climate are Colombo, Lagos, Chennai, Mumbai, Kolkata, many of them in India, coastal India. Hot dry desert, Phoenix in US, Arizona, that is a desert area. Southern United States of America is again all tropical climate, because it is a very large country, Northern side is subtropical, Canada border and all those, central, and then Mexico is again tropical, and just above Mexico it is all tropical climate, because it's similar latitude as, like for example Dallas and Delhi same latitude. Phoenix also would be almost similar, maybe slightly south. So that's it. So that's what it is. Climatic zone, subtropical ones are also given in this table. Same thing I just mentioned, the same for subtropical, subclimates like warm, humid island climate. Modifications are given in this table. Hot, dry, maritime desert climate. There again the modification is lower temperature, humidity is high, and tropical upland climate modification due to the altitude. So that's again captured in this ones. And if I look at an Indian scenario, this is what is important. The red one is hot, dry desert climate. Red one is hot, dry desert climate. You can see part of the Rajasthan, part of Gujarat, part of the Maharashtra also belongs to hot, dry desert climate. The blue is of course cold because of the Himalayan scenario, right? It is cold. And dark yellow, this portion, dark yellow, this portion, all the coastal areas and northeast, this is warm humid. This is warm humid, right? This is warm humid. And this is what is composite monsoon, right? So this is not dry, some season influenced by this, some by this, some might be because of this. So majority portion in the north and central India is composite monsoon climate, right? So what you do actually, how do you classify? First you look into the data, and if for 6 months if the pattern matches with the hot dry, you call it hot dry desert climate. For 6 months it matches with the warm humid climate, you call it 6 or more months warm humid climate. Where it doesn't match with either of them, leaving the cold ones, that's composite monsoon climate. Like 3 months warm humid, 3 months hot dry, that's so that's what it is. So that's given here. Let us say hot dry summarized mean monthly values, temperature above 30, relative humidity below 55, precipitation below 5, these are mean monthly values actually, and number of clear days in a month is above 20. So monthly data you can have, from that you can find out. In warm humid temperature, mean monthly temperature is above 30, relative humidity is above 55, here it was below 55. This is above 5 again precipitation, this is below 5, this is 5, and below 20 the cloud cover is very much there. So moderate is somewhere 25 to 30, below, etc., etc. Now when nothing matches with any one of them, and cold climates are temperature, mean monthly temperature will be below 25, relative humidity is above 55 or below 55, and if it where 6 months or more do not satisfy the requirement of any one of this above category, that you call as composite monsoon. So that's what you can collect the data and find out. Okay. This is again same thing is shown, where 6 months more not, so basically from 2 characteristics you can do: temperature and relative humidity. High diurnal variation, high maximum temperature, daily variation is large, maximum temperature for many months, low humidity, that's hot dry desert. Less diurnal variation, high humidity, maximum temperature is also relatively low, that's warm humid climate. And 6 months do not fit into any one of them, then you call it composite monsoon climate. So I think with this we will like to conclude. We will come to thermal comfort in the next class. We will come to thermal comfort in the next class, discuss. So climate I have discussed, climatic features I have discussed, next class we will have thermal comfort. Okay.